Okay,
there we go. And then does it take a little while for participants to pop in once it's started? Okay.
I need some studio lights in here, guys.
Okay, so there's nobody on but us, right? Yes. Gotcha. Okay. All right. Well, hi, everybody. Why don't we go ahead and get started? Just want to welcome you all to the first webinar in our Back to School series. Tonight, we're going to be talking about everything that you need to know to get started with RobotC in your classroom. John Watson is going to be leading our discussion, and he's the Senior Support Engineer and Lead Trainer for the VEX Cortex platform for us. So you're in really good hands tonight with John. One thing before I turn it over with him, just want to let you know that if you do have questions for us, just feel free to go ahead and type them in the chat. We'll save all the questions until the end, but we will definitely be sure to get to you. So with that, John, I'm going to go ahead and hand it over to you.
Okay, well, hello everybody. Hope everybody's having a great evening. Today we're going to talk about RobotC graphical. So this is a feature that's in RobotC 4.0. Specifically, we're going to be looking at the VEX Cortex platform. This can be used with the VEX IQ platform as well. And I'm going to show how it works, how it ties into the RobotC programming, how you can transition from RobotC graphical into RobotC text, how to go from natural language, from the graphical natural language into text-based natural language, so on and so forth. So really, this is kind of the baseline starting level of programming. If anyone's used RobotC before, if you've used it in years past, you are probably aware of the natural language programming. This is the same type of commands, the same commands, but now instead of it being text-based, it is in this graphical drag-and-drop interface. So without any more kind of further ado, let's go ahead and let's take a look at that. So I'm going to share my screen here in 1 second. There we go. Does everybody see my screen? Okay, looks like we're good. So this is the RobotC graphical interface, and typically this is open. There's a graphical icon on your desktop that you can use to open this, or there's actually a menu in RobotC that you can use to change this over to the graphical interface. And kind of a little short history lesson, the idea we had behind this, so the natural language was kind of the precursor to this. The natural language interface is all our RobotC behaviors that a robot does commonly, like moving forward, moving backwards, turning left, turning right, things like that. Even things like line tracking and some more advanced stuff like loops and control structures and things like that. We built this natural language library to kind of ease students into programming. Because when they start programming, looking at the full RobotC text-based library and all the commands, there's a lot to sift through. There's a lot of options there. It's pretty powerful. So this kind of abstracts out a lot of the stuff that's unnecessary, but it keeps it in an easy-to-use and natural language format. And that is where the text base came from. This is kind of the extension of that, kind of make it more for a younger crowd, for even more beginner programmers, people that have never touched robotics before, people that have never done programming before. And the idea is if you open up RobotC in the graphical mode, you'll see on the left here, I have my function library just like I would in the text mode, but now instead of there being text-based commands, there are these graphical blocks. Okay? And they're pretty basic, pretty simple, and if you look at them, you can actually see that they are kind of self-explanatory. If I want my robot to move forward, well, there's a forward block right here. If I want it to go backwards, there's a backwards block, turn left, turn right. I have things like individual motor control, remote control, line tracking commands, timing commands, and then all of my control structures, my waits, wait untils, while loops, all that up top here as well. And a lot of this, again, if you've done anything with text-based natural language or text-based RobotC, a lot of this will seem familiar to you. If you haven't, this is a great way to get started with it. The nice thing about this is it makes programming pretty nice and easy, very easy to get started. For instance, if I wanted to move my robot forward, all I have to do is drag in a forward command. You'll see it highlights the number 1 right up top here. That's right where my mouse is at, and that's where that line's going to go. So I can drag this in here, and as soon as I release my button, it puts in that forward for 1 rotations at 50 speed. And that's something that's just automatically configured for you. And there you go. If I was to run this on my program, depending on what type of encoders I have in my robot, it'll go forward for 1 rotation at 50 speed. I can change the number of rotations. I can change it to 2, I can change it to 3, I can change it to 3.5. I can change the speed the motors move at. I could put a value of 100 in there, I could put a value of 20. I can even put a negative value, because what it's smart enough to do is it knows that if I put a negative value in here, what's still going to move my robot forward. It's still going to move it forward. It's still going to make the robot move in that direction, because that's what the command calls for. So that's another kind of nice thing that we've put in there. Again, geared more towards younger, newer programmers, so they don't get confused on that type of syntax, that type of behavior with the robot. If you tell it to go forward, it should go forward. You can also change things such as the quantity or the unit type, sorry. You can change it from degrees, rotations, milliseconds, seconds, minutes. So I can do some time-based movement with this. Now instead of going for 3.5 rotations, it'll go for 3.5 milliseconds, a very, very short amount of time. You can change that to seconds, send the program down to my robot, and it'll perform this behavior. You'll notice as we're looking at these blocks, even though it is a graphical block, it's a hard-coded block, and you can't really change any of the parentheses or the syntax or the semicolons, which again, that's kind of the stuff that newer programmers get hung up on, and that's what will cause them problems. It's still baked in there, it's still visible to them. So if we look at the structure of this, it's the forward command, and then there's a set of parentheses. So there's one before the 3.5, and then another one closing after the 100. And this is what you'll typically see in C programming. So the idea is not to introduce something that students will never use again. It's to get them started with the C programming and get them used to things like program flow, things like behavior-based programming, things like moving the robot and controlling the robot and telling the robot exactly what to do. And you can point out to the students as they're going through this all the different little syntax features, show them the different parentheses, show them the semicolons, show them the commas, show them how the different commands are constructed and why they're constructed like that, without having to worry about younger programmers forgetting to type in a semicolon or forgetting to close a brace somewhere or forgetting to put a semicolon in somewhere, because all of it's taken care of for them, but it's not abstracted out. Okay? And again, the idea is this is kind of the first step into C programming. This is not something that they should take and run with forever. It's to get them started with programming. So this is a basic forward command here. If I wanted to change the behavior of the robot, I can do that by changing the parameters. If I wanted to add another behavior, so now instead of moving forward for 3.5 seconds, I want it to go forward for 3.5 seconds and then go backwards for 2 seconds, well, I can just drag in a backwards command, and that's all it takes. I just drag in a backwards command, and again, you'll notice as I'm doing this, the lines on the left are highlighted. So if I drag this on line 2, well, now I have on line 2 my backwards command. If I want to put it before my forward movement, I just drag it up to line 1, and the rest of my code will shift down to accommodate for that. So it kind of reorganizes automatically to keep everything lined up properly for you. Just like the forward command, I have all my parameters. I'm not going to go through each one of these, but you kind of get the idea of how this works. Turn left, turn right, same idea there. You have your options between how far it goes, the unit type, and the speed. Individual motor commands is everything from as simple as setting a motor, turning a motor on to a certain power level, to setting a motor target, telling it to go a certain distance. Okay, so I can say make my left motor go 360 encoder counts at speed level 63, and then brake at the end if you want it to stop at the end and apply a braking force, you can do that. If you're getting into the remote control, we make it really nice and easy. There's tank control commands, there's arm control commands, there's a lot of different commands here. And again, all this is very well documented. It's actually in the, if you're using the IQ platform, it's in the IQ curriculum. We have this all documented in our new documents that are up. Quick side note, we actually have all this now in the documents. Each command has its own separate page. So this is a natural language 2.0, so this might look a little bit different than what you're used to. I'm going to delete some of these commands, just kind of clear up my program a little bit. All I have to do is click and hit delete, and it will delete all that. Coming up in the next build, you have your shift click, so I can click and select multiple options here. So you'll see this coming out pretty soon in the next couple weeks or so. I can hold shift and click multiple ones and delete them that way. Copy, paste, things like that. All that's coming down the pipeline very soon here. But this is all natural language 2.0. For the PLTW users, you guys are probably interested in the natural language that is used in your curriculum, kind of the legacy curriculum, or the legacy natural language that's been around for a while. That is still fully supported in RobotC 4.x, and it's still supported in the graphical natural language. So you guys are not left out of the dust with this. You're not left behind or anything. All you have to do to change that is go into your robot menu, go to the platform type, and then just select the natural language PLTW option. And as soon as I click this, watch what happens off the left side of my screen here. Oops, that's because I was in Vex IQ mode earlier, but as soon as I change that, these are the commands you guys are probably more used to seeing. Okay, so these are actually the PLTW specific natural language commands, things like start motor, stop motor, my robot motion commands, arcade control, line tracking for rotations, moving straight, things like that. And then my until commands that use my sensors to tell the robot to keep doing something until a sensor reaches a value. So this is what you're probably most likely seeing the most in your class, and if you're following the PLTW curriculum, all that is there as well. You still have your control structures up top, so if you want your computer or if you want your robot to repeat the behavior for a certain amount of times, there's a repeat command you can throw in here. You can tell it how many times you want to repeat the behavior. And notice again that we are still following that same C syntax, the same C structure, where I have the command name, I have my set of parentheses with my parameter inside of it, in this case a number 1, and then I have a set of curly braces, an opening curly brace and a closing curly brace. This is exactly what you see with your standard C programming. So you can point this out, and we encourage pointing this out to students and making sure they note it and they notice it and they know why it's important. But again, they don't get caught up with forgetting, the most common one is forgetting that closing curly brace. They won't run into that with the graphical. You can nest different commands in here. So just like normal programming, if I wanted to repeat this behavior multiple times, I could do a repeat loop, and then when I drag in my forward command, when I drag it into line 2, you'll notice that it's nested in. It's actually inside of that repeat loop. If I want to drag another command in, let me do something that makes a little bit more sense. We'll do a wait command, so we'll do forward and then wait. If I drag that into line 3, it's now still inside of that loop. It's inside of that repeat loop. If I want something to be outside of that loop, I simply just drag it out to line 5, which is outside of that loop. When I release it, puts it in there, adds another line in. Just like our other commands, if I want to change the behavior, if I pull this swing turn command, I move it up to the top line, what will happen is it will push the entire repeat command and all the commands that are inside of it down. So again, it does that automatic adjustments for you. And this is true no matter how complex your code gets. It automatically readjusts everything for you, so the students don't have to worry about going through and taking each command line by line and copying and pasting and doing things like that. One of the most important things we do support is the comment block. So you can drag in a comment block, and just like in normal programming, you can type a comment in the top. So this will command is, oh, looks like my audio may have gone up. Am I back live? Okay. Can everybody still hear me? I think we ran into a little bit of technical difficulties. Looks like I'm back. Sorry about that. But yeah, so we have the comment block up at the top, and this goes right into the concepts of pseudocoding and planning out your behaviors. All those really key concepts we want to emphasize to the students. This is where the comment blocks come in. So we have that available for the students. They can drag in as many of these comment blocks as they want. Anything they put in there will be ignored by the compiler, just like a normal comment would be. They can describe every behavior, every action in the program. That's fully supported. Another cool feature of this, if they wanted to test certain parts of their code, rather than having to cut and paste and delete things out and add stuff back in, let's say I just wanted to run the swing turn command and I didn't want to run my repeat loop. If you click one of the numbers next to a command, it turns that command, and in the case of a loop or a structure, it'll turn all the commands inside of it into a comment block. Okay, so this way you can test individual commands because it will ignore your comments when it runs the program. It ignores any text or anything that's commented out. This will allow me just to check the swing turn part of my program. If I click the number again, it turns it back into normal code. I send it down to my robot. We're good to go. If I do my swing turn, I click my swing turn, well, now I'm just going to check my repeat loop. So there's a lot of flexibility on what you can do with this. And again, this is all good programming practices that we want to teach students, that we want to get them used to. All this is kind of boiled into the RobotC graphical natural language. All these commands, again, can be used with the Vex Cortex. Now, you may be asking yourself right now, how does it know when I do this forward command, which side of the robot, which motors are we moving? All that's set up automatically behind the scenes, and what it does is when you start a graphical natural language command is it sets the standard model configuration to a specific model. I believe for this one is the SquareBot standard model. However, if you want to use a different model, you can go into your motors and sensor setup just like you can with your standard RobotC text-based or natural language text-based. You can choose another standard model and it will automatically adjust for you. So you'll notice, if I click apply here, sorry about that error message, that's not typical. As I'm going down here, you'll see when I do my swing turn, it's going to give me the option left or right. It's going to give me forward options. If I do a motor command, so let me do a start motor command. I'll just throw that in there. I can either choose by port number, just like I normally would with my text-based programming, or if my motors are set up and my motors sensor setup, it's smart enough to know which motors are configured there. So I'll do left motor for now. If I change the motors and sensor setup, so I'll go to one of the PLTW test beds, hit apply, hit OK. I can do the same thing there. So it looks like it's got the same motor options there. Yep, so if I want to go to port 8, I could go port 8 and it'll work that way for me as well. Another cool feature that you can do, so for your forward commands, for your back commands, some of the commands like line tracking, you need to know which motor's on the left and which motor's on the right. If you go into the motors tab of the RobotC motor sensor setup, you'll notice from the latest versions of RobotC 4.x, there's this drive motor side on the right-hand side here. If you click on that, it'll actually let you select the left side or the right side of the drive motor for that specific motor. So for instance, if I wanted to set up port 2 as a right side drive motor, I just click the drive motor side drop-down menu, I click right, and now when I do one of the commands that relies on the robot having a left and right side, so my forward commands, my turn commands, my backwards commands, now it knows that port 2 is going to be my right side motor. If I pick port 3, I will make that my left side motor. Now I'll move the left side motor on port 3 appropriately. And I can select multiple motors to be on any given side. So if I make my own custom robot configuration, if anyone's doing the competitions, which I think our fourth hangout is going to talk about that a little bit more. If you build your own custom robot, you can go ahead and configure your robot in here and it will still work with the graphical natural language. Okay, it's smart enough to know that that's the configuration you're using. And then when I go in here, left motor, right motor is now referring to the left and right motors on ports 2 and 3 for this model. So this is kind of the very basic, very introductory level programming. Again, a lot of these commands are the natural language commands. All the commands on here are the natural language commands. You will notice that up top we do have things such as the while loops, such as the if else statements. These are pulled directly from ANSI C programming. So this is the same as what they'd see in C programming. These are not RobotC specific commands. And again, just like our repeat loop, just like all of our other commands, it does follow the same structure. So we have our while keyword, our set of parentheses with a condition inside, and a set of curly braces. Same thing with the if statement, set of parentheses, set of curly braces, and then the else with a set of curly braces. So it does follow that same structure. And the reason I keep kind of harping on that and coming back to that is because the idea is to get them started with a graphical natural language, get them up and running, get them moving the robots, get them excited about robotics. And then the idea is once they're hitting that point where they want to do some more advanced stuff, and when they want to get more into the C programming, and that kind of naturally happens through the course of a robotics classroom, you can actually transition from the graphical straight into the text-based without having to redo all the work. There is a one-click menu option in RobotC under the View, Convert Graphical File to Text. So if you have a graphical file open, and you go to that View menu and you click on that Convert Graphical File to Text, what it will do is it will take a snapshot of the program that you made in your graphical, and it will convert it to a text-based equivalent program. So it's the same exact code that we have in here, but now it's in a text-based program. It's giving me an error right now because I didn't actually select a value for these. So I'll just do, I'm just going to pick two random values here. You'll notice I have the options to check any of my sensor values, any of my motor commands. If I'm in the virtual worlds, it gives me the USB joysticks. If I switch over to physical robots, it will give me all the, whoops. That's because I was in VexIQ mode. Sorry about that. I was doing a little bit of testing earlier. I'll just throw this back in. There we go. It gives me all the VexNet options here. So I can select any of my VexNet joysticks and do that. And then when I convert it over, it'll be the exact same commands, exact same comments, everything that I have in the exact same order. So students can learn all the programming, all the basic movements, getting the robot moving around mazes and sensing objects and things like that. And when you're ready to transition to the text-based, they don't have to worry about trying to recreate everything line by line. They can just convert over, and then you can start to throw in all the text-based options. And this will depend on the classroom, how far they get, and when exactly this comes into play. But again, the graphical is not the end-all be-all programming. It's the stepping stone into this text-based natural language. Okay. When I compile my program now, still giving me that error up. That's because I have an error in the code. You can change your compiler type to the text-based. So if I go over to text-based here, still giving me that error. There we go. So now I've got my text-based function library on the side. This will also open up automatically if you open up the text-based RobotC program. The only reason it was on graphical because I started the RobotC program in graphical mode, but you can always change that later on. And then I can go in and I can fill in. I'm just going to put some numeric values in here for now. Fill in some values here, and we should be good to go. And this is, again, this is where you start to follow along the PLTW curriculum. You can use the graphical with the PLTW curriculum, or you can use the text-based. It's up to you. Once you get to the text-based mode, this is where we actually have our text-based curriculum that you can use either as a supplement or to add in some of the programming. And the idea is we started with the full RobotC programming in our curriculum, but you can use that with the text-based natural language. So once you get to this point, or if you start at this point, you still have all of your natural language commands up on the side. Let me actually trim this down. There we go. So I have all my natural language commands, all the same PLTW natural language commands that you had in the graphical are still here. They're still in the text-based mode. And when I mouse over them, you'll see that it gives me a little tooltip of what each of those commands does. And the nice, really cool thing about this is, let's say I wanted to move my robot forward. Well, I can mouse over, it's going to tell me exactly what this command does, exactly how to use it, and I can now drag this right into my program. And wherever I drag it in, it will put the text-based equivalent of that command in there. So it's got my forward command, and it has all the syntax. So that opening parentheses, the closing parentheses, closing semicolon, and it has the parameter inside of what you should put in there. So I'll put the forward in there, and let's just say I wanted to wait, so I'll drag in a wait command, wait for 2 seconds. So now I have a program that, I'm going to get rid of some of this other stuff, some of these artifacts. I can change my comment. we go. Forward at power level 50 for 2 seconds, and at the end, we'll stop the robot. So there we go. Just like that, I built a natural language text-based program. Again, pretty easy, pretty similar to the graphical. The key difference is here now we're starting to introduce students to the syntax a little bit more. If I accidentally remove one of the letters, well, that will generate an error when I go to download the program, when I go to compile it. So they do have to be aware of that. But again, this is why we want to do this, so they get used to this type of typing, error checking, attention to detail, because this is what they have to do when they're programming in C-based programming languages, or really almost any type of programming language out there. They have to be very clear on what they want, how things are spelled, what commands you're using, etc., etc. Notice too, I've changed my program, I've changed the comment block, I've changed the forward command, I've changed the structure around. If I go back to my graphical program, it's still the original graphical program I have. So these do not directly mirror each other live. When I do that conversion from graphical to text, all it does is it takes a snapshot of that graphical program and converts it to a C-based program, which is awesome because now the students don't have to worry about doing anything in the text-based and messing up their graphical programs that already work. So they can keep their graphical programs as kind of a template, convert them to text whenever they want, make any changes they want. And if they ever need to, they can kind of go back to their graphical template, convert back over, and do so over and over again. So they don't lose anything by switching over to the text-based at all. I can add in other comments. I can add in other commands just like I could before. There's a lot more flexibility with the text-based. One of the things you'll notice if we start talking about things like conditions, well, the graphical will only let you pick one sensor value or one joystick value or one motor to check at any given time. If you get into the text-based, you can check 2 of them, you can check 3 of them, you can check 4, you can check multiple of them. You'll notice too that there's no option for variables in the graphical, there's no options for functions. This is something, we get some requests for it from time to time, but the idea with that is we don't want the graphical to be the end-all be-all, because realistically students are not going to see the graphical blocks in ANSI C programming. What they will see is the syntax. What they are going to see is the if statements and the while loops. So again, just to reemphasize, this is the introduction. This is great to get them started, get them up in programming, but eventually they will want to transition into the text-based RobotC, the text-based natural language. And that's the idea with that. The graphical, you don't have to worry about them missing any semicolons, braces, structures, misspelling any of the words. All that's taken care of for them. I'm going to take a quick break right now. Are there any questions rolling in that we want to address? Not seeing anything yet. I think we might be okay. Okay, I think we're okay. Okay, just give it a second here. Okay, how are we looking, guys? Pretty good?
I think we're good. No questions so far.
Awesome, awesome. Okay, so I'm going to get back to it. All right, so this is a transition from the graphical into the text-based, and there's a lot of research we've done and a lot of documentation we have regarding this as well. So this is not something that I wouldn't say is an exact science. It will depend on your classroom when that switchover happens. Really, it depends on the students and what their comfort level's at and how far they get into the curriculum, how far they get into robotics. So this does vary from classroom to classroom. It's kind of hard to say exactly when it'll happen. Really just kind of gauge and fill up with your students when it's good for them to do so. So this is getting into the natural language for the text-based. So now we've introduced some of the syntax errors. I think we've got another microphone going. There we go. Okay. So this is when we get into the text-based programming. So we've introduced, I wouldn't say some error, but some room for error, some things that students are going to have to watch out for if they go into programming in the future. Okay. And that's the idea. We want them to get used to this. We want them to start doing this. They're going to get a little frustrated with it, but they still have all those natural language commands that they know and love, so they can still use those no problem at all. When we're in the text-based natural language, so I've already explained we can do things like functions, we can do things like variables, we can start to add that in. We can also start to use the actual RobotC commands as well. So when you're in the natural language text-based mode, you have all the RobotC commands available as well. So this is a great launch point, going from that graphical, the block interface, where a lot of the syntax is covered for the students and they don't have to worry about it. This is a good jumping point to, okay, we're going to use the same commands, the same natural language commands, but now we're going to focus on syntax for a little bit, wait for them to get used to error checking their syntax. Okay. Once they're comfortable with that, once they want to get even a little bit more advanced, this is where things like the RobotC curriculum comes into play. This is where things like the RobotC commands come into play. If you want to use the RobotC commands in your natural language text-based program, you can simply type them in. So one of the commands is this motor command. And you'll notice that if I run this, and I'm just going to give it a quick value here, 127, I go to compile program. This shouldn't throw me any errors or any warnings because this is a valid RobotC command right here. Okay, even though I'm in natural language mode, I have the option to do that. So this gives a little bit of flexibility. This is kind of the transition point. As students get more and more comfortable, as they get more and more comfortable with programming and more experience with programming, you can actually disable the natural language options as well. So this is kind of the graduation point when they're ready to go into full RobotC programming. You can just simply toggle natural language PLTW. Notice we have it as a checkbox instead of like a radio button. So if I click this natural language PLTW right now, you'll notice a couple of things will happen with my program. So on the left side here, my function library, it no longer has that natural language option. Okay, so it's been hidden away, it's been taken away from us. It's kind of like taking the training wheels off. And now all my natural language commands in this program are going to generate warnings because natural language commands are no longer able to be used. Okay, so typically what we'll see is classroom will start with the graphical, they'll get used to moving the robot, transition into the text-based natural language, get used to the syntax, get used to typing a little bit. Then they'll start to convert their programs over to RobotC, and teachers will mix in more and more of the RobotC commands. And this is where, again, the RobotC curriculum really comes into play, and I'll show that here in a little bit, because the students can view that anytime they want. They can go online, they can view it, they can write their code, they can do whatever they want with it. Then once they're really starting to get comfortable with RobotC, you kind of phase out that natural language. And that kind of happens organically over time as the students gain more and more experience, to the point where you should be able to tell your students, okay, go ahead and turn off that natural language option, and from here on out, we're just going to be using RobotC text-based commands. At any point, if you want to turn the natural language back on, you just check that box again, it comes right back on. So if a student did have a program that maybe had some natural language commands that they wanted to check, all you have to do is toggle that, and you're good to go again. Turn it off, you just go in, check the box again. You could change over to natural language 2.0 if you want to use that, but again, this is the project lead the way specific hangout, so we're going to focus on the PLTW features. Turn that off, and now I would be able to explain to my students, okay, let's see what we need to change here. Let's take a look at how we can tell the robot to move forward. So all that is covered in natural language, graphical natural language, text-based natural language, and text-based RobotC. Here's a good question though. How do we learn about this text-based RobotC programming? That is where the RobotC curriculum comes into play. So let me pull this up a little bit. Give me 1 second while I share screens and switch things over. Here we go. Okay. And let me switch over to what's it next? It's going to be a little meta. There we go. Okay. Let me pull this, see if I can pull this off to the side. There we go. Okay, I wanted to make sure I wasn't doing that crazy zoom in option. When you share the browser window that also has the Hangout going, it can cause a little bit of issues. There we go. Okay, so this is the main RobotC website, robotc.net. You can find a lot of information on here. Really, the one we're going to look at right now is the curriculum. So if you scroll down, right on the right side here is the Vex Cortex Video Trainer. If I go ahead and open that up, it's going to give me an option here. It will actually redirect. We have just recently updated our Cortex curriculum, which is the top option here. And you see it has a nice shiny new layout. There's actually a fair amount of new features and new information here as well. Things like PID programming, things like the IMEs, the integrated motor encoders, things like using the gyroscope. A lot of that information has been added in. So all that's in the new curriculum. You'll notice a lot of the content from the old curriculum, if you've used the RobotC video trainer before, things like the videos that are still relevant, that are still accurate, we've kept those around. But either one will work. I definitely recommend going for the newer one because it has updated information, it has the IMEs, it has the gyros, things like that. The curriculum is free to view for anybody, so anybody that has an internet connection, they can go on, they can watch this. Great for sending students to do homework or to check things out during study hall or if they're in the library or something like that. For right now, I'm just going to take a look at the movement section. There is a setup section, there are fundamental sections. Let me actually take a look at that first. So I was talking about planning behaviors, the RobotC rules. Here's where you actually start to learn about the RobotC syntax. So this is talking about the actual keywords and the parentheses and the different punctuation that's required and why they're required and all that good stuff. So definitely recommend going through that. And you'll notice that there's actually documents down at the bottom here. If I click on one, we'll do reserved words. If I click on that, it actually shows me some of the reserved words, and more importantly, how can you tell if something's a reserved word in RobotC. Okay. And again, all of this is free for anybody to use at robotc.net. Just go down the side, click on the curriculum, and it'll take you right to here. If I go to the movement section, this is primarily programming focus. That is our goal, is to teach the programming. Again, this is a good thing to supplement the PLTW curriculum if you want to focus on the programming a bit more. You can certainly use it with that. This goes through all the programming options. You can see we're talking about speed and direction, shaft encoders, telling your robot to move straight automatically. You build a program to move it straight automatically. Integrated encoders. Goes all the way through remote control. Talks about the VexNet system, timers, controlling the arm, using the buttons. Then it goes into sensing. We talk about all the different sensors on the robot. These are using the RecBot and the RecBot, the SquareBot standard models. You can also use it with the ClawBot standard models with sensors. You can use it with pretty much any robot designs if you have the sensors on in an appropriate place. So it is pretty flexible with that. And all these lessons are scaffolded off one another. So the idea is the student would start with the fundamentals, work through those, understand the programming machines, understand the roles of programming and the role of the programmer. Two different roles there, but go into the setup. This talks about actually build instructions, setting up the VexNet, things like that. And then when they go through the movement, everything will start to build off of one another. So they start with how do I move my robot forward, and then from that they scaffold into how do I turn, and how do I back up, how do I solve this maze, so on and so forth. So typically you won't want to start just by jumping into sensing, because they'll be talking about things that were covered in earlier lessons. But it is very flexible, it is very adaptable. Certainly recommend taking a look through it. And again, best price on it is free. We'll talk a little bit later on. If you want to install it locally, there are options for that as well. So if you have a school lab, or if you have a network system that's set up that blocks video streaming, or if it blocks downloads or things like that, there are options available for that as well. These are all video-based trainers. So if I open up one of these, I can click this, it would actually start playing my video. And you'll see there it goes through. And the idea with a video-based trainer is instead of a teacher standing up and lecturing for a couple hours, every week and going through at a very set pace. Well, the problem you run into going at that set pace is you're going to have students that are a little bit more advanced that can pick up the programming easier, and they will fly through and they'll understand exactly what you're saying the first time, and they'll want to go, and they'll want to build some programs and run the robots, and that is awesome. And you don't want to rein that in. The problem is that pace that they set, the students that have never done programming before, they kind of get left behind. They can get lost. So you either speed up your training to keep up with those kids that are really advanced, and you lose the kids that have never done this before and never done programming, never done robotics, or you start slowing the class pace down, and the students that are a little bit more advanced that can pick it up, they get bored. And once they get bored, they stop listening to you, and once they stop listening to you, they actually fall behind. So the idea with a video trainer is, instead of lecturing for a long period of time, you can tell the students, go ahead and watch this section of the video trainer. Watch this video, and when you're done, go ahead and check your understanding. So the little quizzes built in here. And then you'll notice right down here we have challenges built in as well. So if I click on this RobotC program here, this is a challenge that is mapped directly to the section of the video trainer that it's found in. Okay, so you could tell the students go through and watch the video, and when you're done, go ahead and start this challenge. So the students that might need 2 or 3 times to go through and view the videos, they can spend the time to do that. The students that pick up the first time they're ready to go, they can start programming the challenge. They get done with that first one, well, there's 2 other challenges they can go through here. And again, the documentation's there for them to reference. It's a very powerful video trainer that we have developed, all research-based, all research-driven. Definitely take a look at it, give it a shot. It's really good to start programming with. Cannot speak highly of it enough. I really do love this thing. But this is kind of tying back to what we were talking about. This is where you start with the RobotC programming. So once you graduate from that natural language, you want to start the full text-based RobotC, this is one place you can go to start looking at that and seeing what's available for you and how to program the robot. And it goes all the way through the sensing. I think the last one we look at here is the LCD display. There's actually a debugger window in RobotC, a little fun fact that you can use to emulate this part if you don't have the LCD. But we're talking about the gyroscope, we've got the line tracker, a lot of stuff that can be used in the challenges, can be used in the classroom, and can be used in competition. If you take a look specifically talking about line tracking, VEX Game Design Committee is great for putting lines on the field that will lead towards scoring objects, that will lead towards goals. If you tell your robot to track that line, well, you're going to end up at that goal every single time if it's programmed correctly. Okay, so this is where the programming kind of comes into play. I'm going to leave that discussion a little bit more for our 4th webinar, which talks about the competitions a bit more. I just want to throw that in there. And finally, the engineering, safety, the hardware, all that's in here as well. So the engineering process, huge one there, project planning, all of that good stuff as well. And we do have some information on the competition programming as well. So again, another quick break. I know we just had one a little while ago, but I'm covering a lot of content pretty quickly here. Are we seeing any questions yet, or are we still doing pretty good?
We are still good on the question front.
Awesome. All right, so let's kind of tie everything together, and I think this will be a great kind of lead into to next week as well. So let's say I've built my code, and I'm just going to throw together a quick program here. I build my code, and I'm ready to send this to my robot. Depending on how much the robot's been used, if this is a fresh out-of-the-box robot, there's going to be a little bit of configuration that you have to do to make this work. Okay, it's unfortunately just a part of robotics. I wish everything would just be plug and play, but hey, you've got to configure it, you've got to build it. A couple different ways you can look at this. In the curriculum itself, we do actually cover a lot of the. Oh, I got to do my screen share back over to the correct screen here. There we go. There we go. Okay. So here's my short little program that's going to move forward, and I'll just do a move forward for 5 seconds. There we go. So in the curriculum itself, it does go over getting started. If we remember back, one of the sections was the fundamentals, getting started with the robot. The setup specifically was setting up the robot. We also have it available in our help documentation, and this has actually just been updated online as of today. You'll see the updated docs are in the newest version of RobotC, which should be coming out soon. But these help guides, is it showing up? Nope, let me do a screen share again. Sorry, every time I got to switch over, I got to switch back and forth. There we go. Okay. So this is available free online. It's installed with RobotC. Here we go. And these are specifically for RobotC itself. So it goes over installing RobotC for VEX, activating the software. If you're PLTW, you'll be activating building license files. Now I know PLTW, you guys get sent out a email with instructions that are very similar to this. Definitely reference that instead of this. We'll actually have the PLTW specific one here as well in the next build. But it's a very similar process, just a different file name. If you want to deactivate RobotC, that's available here. But really the cool thing where I look at the key thing is getting started setting up the robot. So it does walk through the entire setup process of configuring the Cortex, of connecting the hardware, getting the firmware connected, getting the firmware downloaded, the drivers installed, all of that. You always want to start with getting the physical robot connected via the USB A to A cable, make sure that's working. And then there's also instructions for the VexNet system. So if you want to do the wireless programming, we have that available as well. then we show how to open up sample programs, how to use a motor sensor setup. And then we also have, just as kind of a thing here, again, these have been greatly improved in the new version. We do have all of the graphical commands, all the natural language commands, all the commands in RobotC that you'll see and be using in the new docs, and I'll show those here in a second. There actually is a PLTW specific graphical natural language section there. So if you guys just want to focus on that, that's available for you, no problem at all. So this is how you get up, this is how you get started. Once you've gone through that setup process and the robot's connected and the firmware's downloaded, then all you have to do is download to Robot, it sends the program to the robot, and you're good to go. That robot will start running the code. What I'm going to do right now is I'm going to demonstrate this specific code. Now I'm going to show it kind of three different ways. I'm going to show it in the graphical, I'm going to show it in the text-based natural language, and I'm going to show it in the RobotC. And we'll see kind of the difference between the three. I'm going to move the robot forward for 5 seconds in each case. Okay. Let me go ahead and share that. So here's my graphical program. And I'm going to do a, I know why that happened, because I forgot to change back into natural language. There we go. So typically when you're doing this, it is a little bit tricky when you're switching in between graphical and text-based without like opening and closing RobotC and reopening a program. Normally you won't have to go through this process, but there we go. Okay, I want to do SquareBot with IMEs, hit apply. And that's because I was changing the configuration around for demonstration purposes. Now when I compile, we should see, there we go, there's my graphical commands back. Okay, now we're good to go. Okay, so if I want to go forward, and we'll do power level 95 for 5 seconds. Here's my wait. That's my forward for 5 seconds in graphical natural language. You saw and ready. Took me a couple seconds, but took me longer to configure the robot and everything else than it did to actually program this. Forward for 5 seconds, and as a good measure, I'm going to stop the robot at the end. I'm going to demonstrate this in the virtual worlds, and I think next week is when we really start to cover this more and more. But I'm just going to download to a robot, and I'm going to have to switch over my screen sharing again, so give me 1 second here. This is kind of the teaser for next week. There we go. Give me 1 more second, and bingo, there we go. Okay, so I'll leave all this information, CS2N, login in, I'll leave all that for next week. I'm just going to pick a table here. What we should see, if I pick the right robot, which I did not, let me change my robots real quick. There we go. Told to go forward for 5 seconds and then stop. Should go forward for 1, 2, 3, 4, 5-ish. My timing is a little bit off. There we go, 5-ish. 5 seconds, and then it stops. So in the matter of a couple seconds, maybe 30 seconds, I had the program up and running, robot moving. If I wanted to change anything in this, if I wanted to do a point turn rate, power level 95, I will wait for 2 seconds. And again, this is very, very basic programming. And stop. There we go. I download to my robot again, and what it will do is actually it will update. So I made some changes to my code. You guys didn't see that yet, but I'll show you here in a second. I added in a point turn for 2 seconds, then I stop. Reset my robot, clicking the reset button. Press play again, does the forward for 5 seconds, stops, and it should point turn to the right for 2 seconds, and then stop. Okay. And so that's the robot actually behaving those commands. This is a great way to test things quickly and rapidly and accurately. If I go back into my RobotC, there we go. There's my commands. I added in the point turn, the wait, and the stop. That's how you do it in graphical. Very nice, very easy, very simple to get students up and running with this. Let's say I am ready to go to the next level. I've done graphical for a little bit. I want to start doing the text-based programming. I go to View, Convert Graphical File to Text. And to run this now, to run this code now, I want to do the exact same thing. I don't have to change any of the code because it's still that same natural language code. It will ask me if I want to save. So I'll just save. There we go. Simple natural language text. I download to my robot. And what we should see here, I'll switch screens again. There we go. Go back into my virtual world, reset my robot. I press play. Now it's running the natural language code, the text-based natural language code. It's still going to go forward for 5 seconds, and then it's going to do the point turn for 2 seconds. Exact same behavior, exact same performance. All that's changed now is we're in text-based mode. Then finally, if I get ready to go all the way into the RobotC programming, I will go ahead and I'm just going to make a new file for this one. Do a screen share again. Here we go, back to RobotC. I'll make a new file. Because I haven't changed RobotC, I haven't closed and reopened it, and make sure I change my editor type. There we go. So I'll close that. There we go. I'm going to go and turn off my natural language option, so I no longer have those training wheels, so to say. I've taken off the training wheels. If I want to move my robot forward, and I'm going to very quickly just kind of copy and paste prototype this. Great. You can see first movement, it's actually not that bad. It's not that worse. Forward for 5 seconds. There we go. There's my forward command. I can actually copy and paste and just modify a little bit here. And for 2 seconds, left motor going forward, right motor going backwards, change that there. And there we go. So that was, again, that was not realistic for the classroom. Students typically don't copy and paste that quickly if they've never done programming before. But we're still only looking at around, I think it's, 5-10 lines of code total, not including the comments or task main. So not a whole lot of code to make this happen. This is this full text-based RobotC. And now when I send this to my robot, it'll ask me again if I want to save. Robots. There we go. And again, excuse me here for 1 second as I switch screens over. You guys all get to see my beautiful face one last time before we do this. There we go. Go to utility, I'll go to my huge table, and when I run this, I should see the same behavior because it's the same commands, but instead of using the text-based natural language or the graphical natural language commands, I'm using my full text-based RobotC commands. I think I changed the speed values. Yeah, I was using 95 before, so if I change this all to 95. So I changed the actual behavior of the program accidentally. If I re-download this now, we should see this replicate what we saw in the text-based natural language and the text-based graphical. A little bit slower speed. There we go. Alright, so that is RobotC inside and out. That's pretty much the whole nutshell of where you get started, where you can go towards, what to move to. If you're interested in this information, I'm going to kind of kick this back to Leanne here in a second. We can talk more about what this means as a PLTW user. If you're looking for this information, we do have it in the help docs as well. The help docs we have on robotc.net. We also have built into RobotC as well, so if you have either of those, you can check this out. But it does kind of go through this whole progression here. Let me pull this up. Keep forgetting it doesn't screen share automatically. There we go. So I just opened up my help docs, and it's a RobotC language progression. And it kind of goes over some of the more commonly used commands, how they break down into RobotC commands, all of that good stuff. And it does talk about pretty much what everything I covered here. If you've never looked at RobotC or the graphical natural language or anything else like that, this kind of walks you through that whole process. So that information is available. Before I kick this back over to Leanne, there is one more thing I wanted to show you guys. It's really useful for anybody using RobotC. especially with the text-based option. The other website I would definitely take a look at, vexteacher.com. So this is a website we've developed specifically for VEX teachers. If you select the VEX Cortex option up at the top, it will kind of set in VEX Cortex mode. It has links to our curriculum, links to our RobotC page, natural language, engineering process, PDFs, everything. All this information is available. A lot of stuff I haven't gotten to talk to yet tonight, things that other people might talk about, it's all here for you. So definitely take a look at that, see if there's anything you like, see if there's any questions you have. I could go on for another hour here, but I think we don't want to quite do that and listen to me talk for another hour. So at this point, I'm going to kick it back over to Liam. We're going to talk about some of the things that we offer, and hopefully I'll see you guys in another session. It's been awesome.
Okay, great. Thanks, John. It doesn't look like we have any questions, so just to wrap things up a little bit, let me go ahead and share my screen with you guys. Give me 1 second to get this set up. Okay, can everybody see my screen okay? Yes, okay, great. So I just wanted to spend a second just talking really quickly for the PLTW teachers that are out there. You probably have heard a little bit about the upgrade pack that's available to you. Just wanted to mention that this is to add to the standard PLTW license that you get already. And one of the great things about this upgrade pack is that it gives you access to the RobotC graphical interface that John was talking about tonight. So there is information about this. You probably have seen some emails and things like that from us, so go ahead and check that out. It's a really great value. You get access to the graphical interface, but you also get access to Robot Virtual Worlds as well, so you definitely want to check that out. And then one last thing that I wanted to tell you guys about. Okay, as John mentioned, we do have a lot of other webinars coming up for you guys. This was just the first one in our Back to School series. So the next one is coming up on September 9th, which is another Wednesday, just I think 3 weeks from today. And we're going to talk about using Robot Virtual Worlds in the classroom. So that should be pretty exciting and interesting as well. So be sure to check that out. All right, and it looks like we don't actually have any questions, so I think that's it for this webinar. Thank you guys for joining us. Thank you very much, John, for presenting. You did a fantastic job.
Is it okay if I just jump in with one more thing? So one more thing to note with that upgrade pack, if anyone has the IQ platform as well, it does support that. So if you're looking to get into the IQ platform, if you want to check it out, it gives you all the VEX Cortex stuff we talked about, but the really cool thing is if you wanted to try out the IQ platform, you can do it like in the virtual world without even having to buy a robot. So it kind of gives you that more as a benefit. You're getting it anyways. You get the full RobotC suite if you do that, RobotC and Robot Virtual World. So just wanted to mention that because I know a lot of teams, a lot of schools are starting to look at the IQ and get a little bit younger and look at the IQ challenge and things like that as well.
Great. That was a great point. Thank you. Okay, so I think that's it. It doesn't look like we have any more questions, so I guess we're going to call it an evening. Thank you guys very much for joining us, and hopefully we will see you all on September 9th. Okay, bye everyone.
Thank you, everybody.